Hello everybody. Now in this episode of this series, we will understand how to make the data stationary. Before we move forward, let's have a quick recap on the previous episodes, what actually we understood into them. So these are the two episodes or two videos in this series which I have already uploaded on the channel. If you have not seen them yet, I highly recommend you to check them out and then continue this video, right? You would love it. So in this previous video, we understood how to check whether the data is stationary or not. Now, once you are done with understanding that, that's where this particular video comes into the picture, where we are going to understand how to make the data stationary if it is not. Primarily, there are three ways which you can use to make your data stationary. The most simplest one. All right, before I take you to that, one more thing, here is a quick view. So this is what we had understood in the previous video, where we tried to check the stationarity of data by two ways. Number one, this I'm just showing you because just in case if you have not seen the previous video, then you will have some idea, right? So we just discussed there are two ways of finding this thing, of checking out the stationarity of the data. Number one, by rolling statistics, which we did over here, where we find rolling mean and rolling standard deviation. We plotted them all over here and then we saw whether the data is stationary or not. In this segment, we try to do the ADF test, or somebody also call it, or somewhere it is also called as ADCF test, right? Basis on that, we get certain statistics and which helps us conclude whether the data is stationary or not. Now, coming back over here, there are three primary ways which you can use to make your data stationary. Number one, time shift. This is the simplest one. Then log, then finding a square root, cube, etc. So these are the three ways. Rather, I can say whatever the ways are there, these are the most commonly used, right? And there isn't any fixed sequence that first you should go for time shift, then log, then square root and cube, right? You can try any of them in whatever sequence you want, but the most convenient way is to go first with time shift because that's the simplest one. Then it is also not necessary that you try all these three. If you find your data stationary enough on time shift itself, you can go ahead and start building your model. If you find it on log, then you can start with model building. Same goes with square root and cube. If you still don't find your data stationary enough or satisfactory enough, you can combine them also to find a satisfactory outcome. Let's have a look on time shift, what exactly happens over here. So let's say this is your data. If you remember in the first video, we saw this. So here you exactly shift the values by a specific interval. So if you notice over here we are shifting the data by 1 month. How? If you see the number of passengers 112, the data has in the month of January 1949, which is shifted to the February 1949. This is the shift which we have done. After doing this, same goes for 118. It was for February, but that is shifted to March, right? In SAS we call it lag. Okay, and over here we are saying it's shift. So here I am shifting the data by 1 month. If you want, you can shift it by 6 months, 12 months, 24 months, whatever the way you want. It's not necessary that you go by 6 12 only. You can also shift it by 7 months, 8 months, whatever fits well to your data. Then after shifting this, we find the difference of both of these two, the actual one and the shifted one, and whatever value we get, basis on that you can do your stationary test. How does it looks like? And then you can decide to go ahead and build the model. Same happens with log. In logs, what we do is we simply find the log of dependent variable, and then again we do the stationary test. If it looks fine, we can go ahead and build. The same goes for finding the square root, cube, etc. You simply find the square root, or in the similar fashion you can also find the cube. Here I have just shown for square root, and then you can see. If this does not work, see what you can do is you can also find the difference, and then you can do that. Instead of using the passengers, you can instead of using this actual value, you can try to use the log value of this and then square root that and then find the difference and check out the stationarity. So there are multiple ways. All right, lot of discussion. Let's jump to the Jupyter notebook and try to understand it with practical example. The moment you feel confused, just pause the video, put your doubt in the comment section. I'll be happy to help you. Here is what we did in the previous video. Before we move forward, what I'll do is, because we will have to keep on doing this test again and again, so what I'll do is I'll quickly make a I'll quickly put them all together and make a function, and then we will move forward with making the data stationary. That will be helpful. So while I make the function, enjoy. Alright, so here what exactly I did is, first I am trying to, whatever data you supply and whatever the variable you supply for which you want to, check the stationarity, this function I'm creating, because we will have to keep on checking the stationarity again and again. Alright, so for that reason this function we have. Okay, so here first I'm trying to create the rolling mean, then rolling standard deviation, right? And once that is created, here I'm trying to do the ADF test, right, ADF flow test, and then whatever the test comes over here, I'm trying to print over here, right? One print is over here. This will do the statistics printing, and then this is going to do the criticality printing. Okay, and this part is going to plot the data. Okay, let's test this if this is working well or not. To test that, here we have our data called df, and let's see, this is how our data looks like. Okay, we have air df also, air df, which actually should be the same data. All right, no problem. So let's say df dot head. Okay, now we want to test this. So for that, what we can do is test stationarity, and in that supply the data frame name, and then supply the variable name. Variable name is passengers, on which we want to do this test. Remember, this has to be in quotations. Now once you do this, this is what you get. All right, so this is how we will keep on using. So here you see, this is the actual value, this is rolling mean, and this is the standard deviation, and here you have the statistics. Well done. So we will keep on using this function again and again. Okay, so now before we move forward, let's make the data clean so that we could it would be easy specifically for us to continue our practice. Okay, so if you see in the data here, you have a lot of variables. So we are going to, let's create another data frame, let's call it air df, and in that I'm going to say df, and out of that I will just take passengers. This is all that I need. Okay, air df dot head, you see, now that's all that I need. Okay, now let's try the first method. First method we discuss is by shifting the time shift. Now let's just try. So how can we do that? So here I have my data frame which is called airdf, and in that I'm just going to create a variable called shift, right? And you can also say shift 1. Okay, or let's call it shift only, because we will keep on changing this and trying this. Okay, so this is what our shift is. Now after that, what you can do is you say data frame name dot the variable name to which you want to shift, and then say call this function which is called shift, and by how many months if you want to, sorry, do you want to shift it. So if you want to shift it by just 1 month, you don't need to put any value over here. Okay, if you want to shift it by more than 1 month, then you need to put the value. For example, if you want to shift it by 4 months, then just put it 4. Let's try with this simple one. So here we have air df, and dot, here we are going to say, this thing, like you can see over here, right? So here the value is shifted. Now the next step is finding the difference, right? So let me just create another variable which I would say, look, I'm trying to keep it to the absolute beginner level, right? But if you find it little annoying, so just try to watch it in double speed or maybe 1.5. Now the next thing which we're gonna do over here is this. We will subtract airdf dot passengers minus this thing. Okay, now let's just see how the data looks like. Okay, so this is done. Now the next thing is testing the data, or let's just try if this looks much better. No, it's the same thing. Okay, so this is looking same. Now the next thing which we're gonna do is check out whether check out the stationarity of this data. Okay, so test stationarity, and the data frame which we have created is airdf, and in that what we are going to use is shift difference. This is the variable which we will be using. Okay, so let's just call it over here airdf. This is the data frame name, and the variable which we want to use is this. Now just hit enter and see the magic. Oh, it showed the error. Let me just figure out what the error is. Xawk contains information or NANs. Okay, so what you see over here is this NAN that is creating problem, so that's not an issue. Let's call it drop NA, and let's just do this and let's see if it worked. Yeah, so here is what we have. Now you see this is still much better, right, from as compared to the original data. Or originally we had the data like this, right, and after doing the shift transformation, this is how the data looks like. So this was the shift transformation. Next comes is log transformation, right? So let's just try to see how we can do that. So if you have not understood it pretty well, so before I move forward, let me give you a quick view. So if you see over here, test statistics is minus 2.65, while the criticality is minus 3.4 for first percent interval, and you see this is somewhere closer to this criticality, right, and p-value is 0.08. over here you see mean is fairly looking constant, but the variance or standard deviation is showing a kind of trend pattern. Okay, so this was the one test. Now let's move forward and do the another test. Before we move forward, let me just create a subset of the data again, and here I would just say passengers. Okay, let me just do a quick copy paste passengers, because I just don't want to waste the time. Your time is pretty much important, and let's just see if this looks good enough. Log df dot head. Yes, now here we have the data. Next step which we're gonna have is find the log of this value. Okay, for that what you can do is you can just simply say log, and inside that you just supply the variable which is log df, and out of that you can just take passengers, right, and let's see log underscore df. How does it looks like? So here is what we got. Okay, now there are two things. Number one, you can directly check the stationarity on this log variable. Number two, you can combine the above shifting method into this and then find the difference with log, not with passenger, and then you try to check the stationarity. I'll go ahead with the simplest one first, and then we will see if we require to combine it. Let's check the test stationarity. Okay, in this the data frame name which I want to use is logdf, and the variable which I need to use is not passengers but the log. Okay, do I have no, I didn't get the error this time because we didn't use the shift thing. Okay, all right, this looks good. The variation is, you know, the variance is pretty constant, but original data and this mean is still showing the pattern into it, right? But just looking at the graph, we cannot conclude it pretty well. So let's have a look at the statistics. So in statistics, if you see this minus 1.7, this is fairly, good compared to the previous one. And if you see, the p-value is 0.42. And what is the p-value that we have in the previous one? 0.08. So still this one time shift looks much better compared to this log thing, right? So, and if you see, this is the mean curve and this is the standard deviation curve. All right, so this is what we had for this one. Now let me just keep this one is for here. I have an Excel and I'll put all the things over here. Let me just say shift wala part is here, and this is going to be the log, so that it will be just simple for us to quickly have a comparative view. Okay, let me just do this. Okay, now if you see, log is showing you the greater p-value compared to the shift one. Okay, now let's move forward and try to do the square root. For square root, again, what I'll do is I'll create another subset of the data. If you want, you can keep on using the same data, but just for simplicity, I'm going to use this over here. Oops, sorry. Here I have to use passenger. Again, I need to copy this, and here what I'll do is I'll just put it over here. All right. Let's have a quick look on this square root df, and how does this look like? All right, so this is looking like a series. Now let me make it data frame. Okay, now here we have it fairly enough. Let's create another variable into it, and I would say into this sqrt square root and np.sqrt. Inside that, let's just apply this variable which is df and this passengers. And now you just go ahead and have a look on this. Perfect. Now let's try to plot this. Now let's just try to check the stationarity on this data. Test stationarity. Into this, supply this data. The data frame name is sqrt.df, and the variable which we want to use is sqrt. Let's just run this and see how does it looks like. Oh, this is terrible. Not much better, huh? Let's have a look at the p-value, that is 0.9, and then test statistics is negative 0.34. Let's just take this. By looking at the graph, it is looking terrible. This was the square root method. Here we got that also. Now the next thing which we can try is cube root. Still the shift thing is looking better. This has p-value of 0.08 and here it is 0.9. Alright, let's move ahead and try the next one. Next one we're gonna have is, let's take cube root underscore df, and here I will again take df subset passengers. Df subset passengers, and let's just have a look at head, and this is how our data looks like. Now let's create the variable. In this we will say cube root equals to df, and into this I just need to put this in np.cuberoot. np is nothing but numpy library. Okay, all right, here I got some problem, and the problem is right here. Instead I should use this as the data frame. Now we got it right. Here is what we have. This is cube root. Okay, now after finding the cube root, the next thing which comes is testing the stationarity. All right, now let's just go ahead and test the stationarity. The data frame name we are going to use is cube root, underscore df, and the variable which we will be using is this. Now let's just see how our data looks like. Now this is what we get over here. By looking at the graph, it is not looking much different, but let's just see how is it looking over here. Alright, so if you see it has 0.8, still the shift one is giving you the better result, isn't it? Shift method is giving you 0.08 p-value, and test statistics also fairly close to it. Now let's just try to combine log and square root both. So what I'll do is, first I have the log underscore df dot head. Here is what we have. Now let me make a subset and let's call it log df2 log underscore df2 equals to log df, and out of that I will just take the passengers and the log variable, and let me show you the sample data. This is how our data looks like. Now we have to perform the square root on log variable. Okay, so let's just say log underscore df2 log square root. Okay, and now over here let's call it np dot square root. Inside that, what we're gonna do is np dot square root, and inside that I will use log df, out of which I will take the log. So here we are just trying to find the square root of this log data. Now the next thing what you can do is you can find the difference of these two, and then we can check the stationarity on top of that. Or maybe let's just try to figure out the stationarity on this variable itself. Okay, because we have already combined two things, right? So let's just see how does it looks like. Test stationarity, and inside that I'm just going to put this particular data, which is nothing but log df2, and over here the variable which I will be using is this. Let's just see how does it looks like now. Okay, and what is the p-value? Here we just combined log and square root. Okay, so p-value it is giving us of 0.3, which is still showing that shift method is doing better, right? If you go by this test statistics. Okay, and the test statistics also, you know, somewhere I mean, we can say it's close to this criticalities, but p-value you see still shift one is much better. Now what you can do over here is, next thing you can try to, you know, shift this particular value. Let's just try this. Okay, over here what I'll do is log df2, and let's call it log shift diff, and over here we will say log square root. We are combining multiple things, so let's just see how does it looks like. Shift by 1. Okay, now this is how the data is looking like. This is shifted. Let's see how does it behaves over here, and we would have two variables already created inside it, rolling mean and all those things. Let's just see what happens. Okay, it is saying something NaN problem. Okay, because this shift value, right? So here I will say drop Na, and this is this working? Oh, it's pretty good, isn't it? Now if you take this All right, so here the test statistics is 3.07, which is fairly close to criticality 1%, and p-value is 0.02, and the p-value which we have for shift is 0.08. So this is doing much better, which is log plus square root, log and square root. We combined three things over here, right? A square root, and then we combined shift as well, right? So when we combined three things, we relatively got a much better result, right? So this is how you can try different ways, right? And then you will get you may get a very good result, and then using that you can move forward to build your model. Now in the next video we will start with building the model, and we will see which one to pick, which of these are doing better. Most likely we will try to go with this either shift method or the whichever has performed better, right? After shift, the log method has done pretty well, so we can go with log method also. And this is the awesome, right? So we can just see whatever is easy or simple to understand, we will go ahead with that. Okay, thank you very much for being with me, and see you in the next video.